Welcome again to another instructional video. We just completed the integral of cos squared theta d theta. Now let's look at the integral of sine squared theta d theta. It is found very much like it. Actually, since we have done the integral of cos squared theta d theta, let me write the result of that here to remind us. We're basically home free, but after I make this commentary, I'm going to pretend we didn't know that. But we have already done in the last video that the integral of cos squared theta d theta is a half of theta plus a quarter of sine of the double angle 2 theta plus some constant of integration. You may say, well, why does that help us? And the reason why that helps us is simply because of this. The integral of sine squared theta d theta can be written as the integral of 1 minus cos squared theta d theta. And I hope you'll appreciate that when we distribute, this is going to be the integral of d theta minus the integral of cos squared theta d theta. Okay. And, well, we know everything that we need to know on both of these integrals, that the left one is just theta, and the right one is going to be minus all of this result. Okay, so it's going to be minus a half of theta plus a quarter of sine of 2 theta plus, I'll just write momentarily the c in my beloved c hat fashion. And so now if I distribute that minus in, we're going to get a theta from this term right over here minus a half of theta. So 1 theta minus a half is going to be a positive a half theta. So we're going to get a positive a half theta here, and then minus a quarter of sine of 2 theta, and then minus c hat we'll just write as plus c. Okay, so we already have the answer very simply, given the fact that we did the work previously for the integral of cos squared theta, okay, d theta. Now, let's just pretend that we had not done that work. And the reason why I want to go through this one more time is, in case you didn't watch the other video, let's just develop this from the ground up because it's really not that difficult to do after all. Well, one of the things that we've asked us to memorize are these sum formulas of the angle sum formulas in trig. So let's take a look at the following. Let's say, okay, cos of a plus or minus b is equal to cos of a cos of b minus plus, remember those get flipped, sine of a sine of b. And, well, if I went ahead and I said, let's do this, let's say cos of theta, and let's just again look at the plus, cos of theta plus theta, that's going to be obviously cos squared theta. Again, it's going to flip the sign, minus sine squared theta. And now I'm going to write this cos squared as 1 minus sine squared theta. So this is going to equal cos of the double angle is equal to 1 minus, I have minus sine squared here, and I have a minus sine squared there. So I'm going to get minus 2 of those sine squares. And if I back solve for the sine squared, we'll go step by step. Let me just take this to the other side, and I'll bring this to that side. So I get 2 sine squared theta is equal to 1 minus cos of the double angle. And now let's divide both sides by 2. I get sine squared theta is equal to a half minus a half cos of the double angle. Okay, and now, again, like we said in the previous video, we have a nifty little relationship here. Instead of integrating this thing the integral of sine squared theta d theta, which is a little bit hard to do, we'll sub in the right-hand side, which is its equivalency, or the identity of that. So we can, instead of doing sine squared theta d theta, we'll do the integral of a half minus a half cos of 2 theta d theta. And now, once again, we distribute, we get the integral of a half, we'll bring the half out, that's a constant d theta, minus the half times the integral of cos squared theta d theta, and we'll do a quick u substitution. U is equal to 2 theta, that means du is equal to 2 d theta. That means that d theta is equal to a half of du. Alright, so then we see that this is equal to a half of theta minus a half of the integral of cos of u, and instead of d theta we're going to write that as a half of du, and so we get a half of theta minus a quarter, because half times a half is a quarter. The integral of cos u du is equal to a sine of u, and then we get a constant of integration coming out of all of that. And now let's sub back in for u. So we find therefore that the integral of sine squared theta d theta is equal to a half of theta minus a quarter of sine of the double angle 2 theta plus c, and that should compare identically with what we did in the opening minutes or seconds of the video up here. Let me see. Yeah, if you come back up here, you have, let me do this in red, you have a half of theta minus a quarter of sine of the double angle plus the constant of integration, and everything checks out. Okay, thank you for your attention. We'll see you in a future video.